this example, we're going to compute probabilities of a binomial experiment. Let's read what this example says. Suppose the probability that a student will forget to bring his or her calculator on the day of the test is 2%. Find the probability that in a class of 35 students, 4 students forget their calculator. That's question A, and then we have more questions here. Nobody forgets their calculator. At least one student forgets his or her calculator, and then we have a few more. So let's see how we answer all those questions. So first we're going to start by confirming that we are dealing with the binomial experiment. So binomial experiment always has only 2 possible outcomes. We're going to try to describe them here. But what is the binomial experiment itself? Well, in this example, we have a class of 35 students, right? And we're trying to calculate probabilities, or will need to calculate probabilities, that certain number of students forget their calculators. So this means that experiment consists of asking each student whether he or she forgot their calculator. So you ask student number 1, have you brought your calculator? What are the possible answers? Well, yes or no, right? So either student forgot the calculator or he or she didn't. Then you ask the next student, and that's the next mini experiment. So these are trials, right, of that binomial experiment. Then you ask next student same question. Have you brought your calculator? Again, answer is yes or no, only 2 options, and so on and so forth. So our trials in this example are literally asking students or checking if student forgot calculator or he or she didn't. Now, so what are the 2 possible outcomes then? Well, either student brought calculator or forgot. So in short, let's say forgot calculator or didn't forget. Okay, so these are 2 possible outcomes. Now, when we refer to the outcomes of the binomial experiment, we call them either success or failure. So what outcome is referred to as a success in this example? Keep in mind that success doesn't mean something positive. Success is the outcome that we're counting probability for. So if we read the question here, it says find the probability that in a class of 35 students, 4 students forget their calculator. Nobody forgets their calculator. At least one student forgets his or her calculator. So it looks like we're calculating probabilities for students or a certain number of students forgetting their calculators. It means that success is going to be that student forgets his or her calculator. So a student forgets his or her calculator. Again, with success, because this is what we're counting. This is what we are counting. Okay. Now, next, the question is about the number of trials. We already mentioned that it's going to be 35 trials because it's 35 students, and for each student we have to check whether student forgot or didn't forget calculator. And when we deal with binomial experiment, another requirement is that each trial has the same probability of success. And that's the case here. So we know that historically, probability that student will forget to bring his or her calculator on the day of the test is 2%. That's kind of a historical percentage. It means that every time we ask student or check if student brought or didn't bring their calculator, the chance of not bringing calculator is that historical 2%. So 2%, or we're going to convert that to a decimal, that's 0.02. That's given, right? So that's where we get this from. So we also can see that trials are independent of each other. So this means that if one student forgets their calculator, that has no effect on another student forgetting or not forgetting their calculator. So trials are independent of each other. So we have all the requirements of the binomial experiment, and that means that we're going to be using, and to answer those questions, we're going to be using calculator and binomial distribution functions that we have in the calculator. Let's see how we use them. So the first question is to find probability that in a class of 35 students, 4 students forget their calculator. So the way this question is asked, it's asking if exactly 4 students, so the keyword, even though it's not written here, I want to say it, or even like write it. So it's exactly 4. So what's the chance that on the day of a test, when instructor checks with each student whether they brought their calculator, exactly 4 are going to forget their calculator? What's the chance for that? So we have 2 types of binomial distribution functions in the calculator. To find both of them, we have to press second, then we're going to press vars. Above that it says dist for distributions. That's how we access all the distributions. And among the distributions, we have to find binomial distribution, and that's when we scroll down to lines A and B. So here they are, binom PDF and binom CDF. So function that we use for calculating the exact number of successes, that's our keyword right here, right? Exact number of successes is binom PDF. So once we open that function, we have to record the number of trials. What is the number of trials? In our example, it's 35. What's P? P is the probability of success in each trial right here. It's 0.02. And now X value, well, it's the number of desired outcomes. Exactly 4 students, so I'm going to enter 4. If your calculator is not showing you this list, then you will just have to enter those 3 numbers separated by commas. You'll see in a second how it's going to look on your calculator if you don't see that. So I'm going to press enter. Well, this is how it's going to look on your calculator. Well, you're going to have parentheses open, then by hand you have to enter those 3 numbers in that exact order: 35, comma, 0.02, comma 4, close parentheses, and then press enter. And that's how you get the result. Well, that's the probability. Let's write this all down. I have some space here, so that's where I will write it. We're using binom PDF df function. That's where we need to remember that it's for the exact number of successes. And we're entering numbers 35.02 and then 4. And the result is, what did I say? It's 0.004. I'm rounding to 3 decimal places, and that's what we'll get. 0.004, which is approximately, what percentage is that? If I move decimal point 2 places to the right, it's going to be 0.4%. So it's less than 1% chance that exactly 4 students are going to forget their calculators. Okay, so that's the answer for part A. Let's try part B. In part B, it says that nobody forgets their calculator. Well, what is that number, nobody? How many desired outcomes is that? How many desired successes is that? 0, right? Nobody means that 0 students forget their calculators. So using probability notation, I'm going to use probability and then put here 0. That is from nobody. Now this is also probability of the exact number of successes, exactly 0. And that means that we'll use binom PDF again. That's binom PDF. And the numbers that I will be entering, well, again, 35 trials, 0.02 probability of success of each trial, but then the last number I'm changing to 0. It comes from here. Number of desired successes. Let's see what that equals to. second vars, scroll down to binom PDF. I already have 35.02, and now 0 I'm changing to, 4 I'm changing to 0, like that. Enter, or you have to enter them manually, all inside the parentheses separated by commas, right? So enter, and that's the result. So 0.493, which is approximately 49%. So that's a pretty good chance, right? Very close to 50% chance that no one forgets their calculator. So that's the result. Okay, so let's try the next one. This time it says at least one student forget their calculator. So at least one. Let's write that using words at first. At least one. In this case, this event does not include just one exact number of desired successes. At least one includes several cases, right? So what kind of cases are included here? At least one, it means it's one or more. So it's either 1 or 2 or 3 and so on and so forth, up to 35 students. So what's the probability of one of those events happening? Let's think how we calculate it. So first of all, it's no longer going to be binom PDF. Well, I could use binom PDF for finding each individual probability and then adding them up together, but it's going to be a lot of numbers to add. But the way we can approach this is we can use the complement rule. Remember, according to the complement rule, to calculate probability of any event, we can take 1 and subtract the probability of the complement of that event. So what's going to be the complement of this event? So complement is going to be an event that includes outcomes such that they're not included here. So what kind of outcomes are not included in here? We have 1 through 35, but something is not included. So what is that? Well, what's not included here is the 0 outcome, right? We don't have number 0 here. And what is the 0 outcome? 0 outcome means that 0 students forget their calculator. So nobody forgets their calculator. So according to the complement rule, again, that's complement. To calculate probability that at least one student forgets their calculator, which are all those cases, we have to take 1 and subtract probability of nobody forgetting their calculator. And that probability we already know. We calculated it in the previous question, right? It's right here, 0.493. So we're ready to subtract minus 0.493. And that is 0.507, which is approximately 51% chance. So there's about 51% chance that at least one student in that class forgets his or her calculator. Now, next question. Next question says that we need to calculate probability that more than one student forgets their calculator. Now, that sounds very similar to what we just did, right? So there was at least one, and here it's more than one. Well, we have to be careful with that wording. At least one and more than one are different things. When we have at least a number, well, that's that number and more, or more. But when we have more than a number, we have to start counting with the next number. So what I mean is that if we have more than one, that includes cases starting with 2. It means that either 2 students forget their calculator, or 3, or 4, and so on and so forth, up to 35. And since it's still somewhat similar case, we're going to use complement rule as well. But this time it's going to be 1 minus what's the complement of this event. The complement of this event will be event that includes outcomes that are not included here. What is not included there? It's 0 or 1 cases, right? So That's what we need to find right now. Find its probability so we can subtract it from 1. How do we find it? There are two options, at least two options, and one of them is to find each individual probability exactly 0, exactly 1. Student forgets their calculator, and that's by using binom PDF, and then adding those two together. Or we can use binom CDF function. That function calculates probability up to a certain number of successes. And when I say it's probability of either 0 or 1 students forgetting their calculator, I can also say that it's same as up to 1. That's same as up to 1, right? And as soon as I see up to 1, I know I can use binom CDF. So binom CDF. So that's going to be 1 minus, oh, that's a huge minus. 1 minus binom CDF. And I'm using binom CDF if I have case for up to a certain number of successes. Now numbers that I will be entering in the calculator will be, the first two will be exactly the same. I have 35 trials. Probability of success in each trial is 0.02, but then the last digit will be, well, that number up to what number? Up to 1. So that's the number up to 1. Let's see. Second bars. Scroll down to binom CDF this time. That's line B. Enter. So 35 trials, 0.02. That's probability of success in each trial. And then it also says X value, but the meaning of that line X value is different this time when I use binom CDF. It's up to 1 success. And then enter. If you have slightly different calculator, then you'll have to use these numbers in order separated by commas like that. And I get 0.845. That is 0.845, which is approximately 85% chance, right? So it's an 85% chance that more than one student forgets their calculator. That's very likely. Okay, and then the last question is to find what's the probability that fewer than 3 students forget their calculators. Let's write that. Fewer than 3. Okay, once again, we have to be careful with the wording. What does it mean, fewer than 3? Well, fewer than 3, it means that's either 0 or 1 or 2. However, 3 itself is not going to be included. So it's either 0 or 1 or 2. How do we calculate this probability? I can see that this list of cases, 1 or 2, 0 or 1 or 2, I can rephrase as up to 2. Up to 2 successes, right? Up to 2. Well, as soon as I was able to rephrase it as up to a number, it means that I can use binom CDF function. So that's going to be simply binom CDF. And the values that will enter will be 35, 0.02, and then what is the last digit here? Well, that's from here up to 2. It means that I will have to use 2. And then again, up to makes me use binom CDF. Let's see what that equals to. Second vars. Scroll down to binom CDF. 35.02, I have all that, and then yeah, X value is 2. Press enter. That's what you're entering if you didn't see that list on the previous screen, and then press enter, you get 0.967, which is approximately 97%. So it's a 90% chance that fewer than 3 students forget their calculator. Okay, so that's how you compute probability for binomial experiment using TI-84 or 83 calculator and binom PDF and binom CDF functions.